waves, just briefly if you can, if you have the time. If not, maybe after 4 o'clock, after the session is over, I could briefly show on smart how we could time window the reflected wave and just try and keep it to direct sound. Now, आपका जो measurement system है, जैसे कि आपका स्मार्ट है या कोई भी आपका FFT प्लेटफॉर्म है, वो कभी आपको झूठ नहीं बोलेगा. जो है, it's going to show you the absolute truth. So don't doubt its intentions unless you have some faulty equipment, which I think you need to make sure that you don't have. That's something that before you go out in the field, it's not going to, you don't need to doubt its measurement. आपको कभी भी संदेह नहीं करना है कि आपका जो measurement आ रहा है वो सही है, गलत है. उसको देखने का तरीका अलग है. जैसे कि आप देख रहे हैं, एक एंगल से आप देखेंगे it's you know you're seeing a square, और दूसरे एंगल से आप देखेंगे आप उसको गोल दिख रहे हैं. So you're basically seeing two things on the same part, in just the way you're seeing it is different. Why I'm saying this is because there are various studies in terms of people use different processors. अभी जैसे एक study है by Bennett Preston, you can look it up online, and he has used 20 different processors. उसने 20 अलग-अलग DSP use किया है, right from the XTA to an Electro Voice या DBX या Clap Technique, Symmetrix, Kling and Frintag, Dolby या Studer, और उन्होंने एक ही तरीके का सिग्नल दिया है, and he's used the same EQs on all the DSPs, where he said, okay, I'm going to use a Bessel high pass filter, मैं 2-3 EQ डालने वाला हूँ, एक shelving EQ डालने वाला हूँ, and all of them gave a different result. So get familiar with one processor. आप जो भी system use कर रहे हैं, use one, build up on one platform, and make sure that you know what is happening with that one single this thing. If you're using two different brands, don't expect that both the brands or both the processors are going to show the exact same results, because they all vary in their response. So we have a lot of scope for improvement. There is no standard जो follow सब करे, जो tolerance standard है, जो कि यही tolerance के अंदर होना चाहिए. सबके response थोड़े फर्क आएंगे. So जो भी आप use कर रहे हो, make sure you are comfortable with it, whatever DSP you're using. Again, this is not to tell you all to use one particular DSP, but whatever you're using, stay with it and continue using the same one. Again, this is a response of a measurement microphone, जैसे कि Behringer का ECM 8000 है. अगर उसके 85 माइक्रोफोन्स को हमने अलग-अलग मेजर किया, you can see you're not getting a single trace. मतलब stay with one microphone, don't interchange your equipment when you're measuring too much, because it's all going to vary with time. So now going forward, we are just going to talk about some important formula जो आज हम use करने वाले हैं. एक जो है कि Ohm's law. If quickly you want to just narrate the Ohm's law, is just basically saying that a conductor has a resistance of 1 ohm if a voltage of 1 volt applied across it causes the current of 1 ampere to flow through it. Basically बहुत simple formula है. जो voltage है वो है current into resistance, and ये position जो change करेंगे, current is equal to voltage upon resistance, या resistance is equal to voltage upon current. It's something that's familiar with all engineers that you guys would have been using so far. And again, we're going to see power. Power is dissipated in the conductor when you're seeing a current flowing through a conductor and a voltage applied across it. You're seeing a voltage into current. This power is voltage into current. हम हमारे power amplifier का उसका voltage calculate करने के लिए ये use करेंगे. And we don't usually use voltage into current because voltage and current are both vector quantities, and they are not always in phase. I don't want to get into too much complication. मेरे को ज़्यादा ये matter को complicate नहीं करना है. But the most common one that we'll be using, because we are using हमारे amplifier जो है सब voltage amplifier है. हम 1 या 2 volt amplifier के अंदर देते हैं, और output में हमें you'll get 80 volts or 100 volts or 120 volts. ये हम amplifier को, ये voltage को amplifier कर रहा है. So we are getting, this is all of these we are going to be calling voltage amplifiers. So we are going to be replacing जो हमने हमारा जो previous formula था. If I'm just going to quickly mark this, जो current है, जहाँ ये voltage into current, हमने यहाँ देखा है कि current is also equal to voltage upon resistance. तो हम current को V by R से replace करके हमें मिलता है V into V divided by R. So power is equal to square of voltage divided by resistance. So we're going to use that, and we're also going to be talking a lot about time. जो frequency है is, again last time we did it, time is a time period of one wave and the frequency is the number of waves passing in 1 second through that point. So just a reciprocal, दोनों का interchange होता है and this is in seconds. अगर आपको मिली सेकेंड में करना है तो you'll do 1000 upon frequency, एक सेकेंड में 1000 मिली सेकेंड होते हैं. So that's how you're going to get time. Time is equal to 1000 divided by frequency and you're going to get that in milliseconds. जो भी हम सुनते हैं उसका रेंज बहुत ही ज़्यादा है. The range of the human hearing is 1 trillion is to 1. So we can't be representing anything in numbers in such a large, such a vast range. इतने बड़े रेंज में हम numbers को represent नहीं कर सकते हैं. इसके लिए we are going to be using the response. We're going to be using decibel. And I won't get into too much, details, but just into basic formulas. And again, just to give you a basic idea about how the decibel is, जो हम ऊपर देख रहे हैं ये हमारा normal ruler है. Ruler पे सारा increment equal है. You go from 0 1. You have every division is an equal space division. So you have 0 1 2 3 4 5 6 7 8 9 10 is marked, and then 10 1 2 3 4 5 11 12 13 14 and up to 20, and it keeps going on. जो हमारा I've tried to show it with some coins and notes. जैसे हमारा logarithmic scale है, you're going to be going from आपका 1 पैसे का सिक्का है, 2 पैसे का सिक्का है, 5 पैसे का सिक्का है, 10 पैसा, and it keeps going on, 25 पैसा, 50 पैसा and 1 rupee, and then again you go from 1 rupee, 2 rupee, 5 rupee, 10 rupees, and then from 10 it goes on 20, 50, 100. So ये जैसा increment है, this is a similar increment that you're going to experience on a logarithmic scale. वोल्टेज मेजर कर रहे हैं, जब हम लॉगरिथमिक में जाएंगे उसको हमेशा विल बी कंपेयरिंग इट टू अ फिक्स्ड वैल्यू, या हम कंपेयर करेंगे. हम वी आर गोइंग टू बी सीइंग जो हमारा डिस्टेंस के साथ जो साउंड का लेवल ड्रॉप होता है, हम अपना SPL 1 मीटर के डिस्टेंस पे मेजर करेंगे और देखेंगे कि इसका SPL इतना है तो 20 मीटर पे क्या होगा. सो वी आर गोइंग टू बी यूजिंग द रेफरेंस, जो हमारा 1 मीटर पे जो SPL है, वी आर गोइंग टू यूज दैट एज अ रेफरेंस एंड देन कैलकुलेट व्हाट वी आर गोइंग टू एक्सपेक्ट एट 16 meters or 20 meters है जहाँ भी हम मेजर कर रहे हैं. So you're always in logarithmics, you're using a reference. And examples of scalar logarithmic measurements is power and intensity. Power is something that you all know. Intensity, just to give you a brief idea, is it's the power that's carried by sound waves. Again, I don't want to get into too much detail. It's the power carried by sound waves per unit area, and of course in a direction perpendicular to that unit area. Units is watts per meter square. Not something that we're going to use today, but just as an example I'm giving you. जैसे कि मैंने बोला, हम हमेशा में हम रेफरेंस यूज़ करते हैं. तो आपने बहुत से एरियाज पे देखा होगा कि एक वैल्यू दिया है पुराने इक्विपमेंट dBm. dBm में 10 log जो आपका मेजर्ड पावर है टू रेफरेंस पावर, और जो रेफरेंस पावर है वो 1 milliwatt है. एंड दैट इज हाउ यू गेट योर एक्चुअल dBm मेजरमेंट जो भी आपका इक्विपमेंट है. Intensity is again your 10 log into the reason for showing is that we are all using the 10 log equation for these items. So you are measuring the intensity at one point. It's not very easy to measure intensity. It's a more complicated thing than just using a sound card to measure. And उसका reference जो है is 10 raised to minus 12 watts per meter square. Vector is going to be using magnitude as well as direction. An example of that is voltage and pressure. जो हमारा dB SPL है, हमेशा बोलते हैं ये साउंड का इतना SPL है, वो हमेशा वो साउंड के प्रेशर को मेजर कर रहा है. एंड द रेफरेंस ऑफ दैट इज जो हमारा कान जो हवा में जो प्रेशर जो लेवल से चालू करता है is using that reference as that level as the reference, and that is the reference level is 20 micropascals or 2 into 10 raised to minus 5 pascals in Newton per meter square, or it's also 2 into 10 raised to minus 4 dynes per centimeter square. Again, don't get into this, you don't need to measure pressure, but just that we are using this value as a reference when we are measuring SPL. Most all equipment that you see today is always more or less using dBu, और यहाँ पे हमारा रेफरेंस जो है dBu is a voltage measurement. इसका इक्वेशन है 20 into log V1 by V0, और हमारा V0 का रेफरेंस है 0.775 volts. ये 0.775 volts कहाँ से आया? क्योंकि your terminating impedance on your lot of पुराने कंसोल में 600 ओम होता था, और टाइम के साथ ये 600 ओम बदलते गया. You get different 250 ohms or whatever. So 1 milliwatt जैसे कि हमारा पुराना DVM का reference था, that was the power dissipated when 0.775 volts was applied to 600 ohms. On with time हमने देखा कि the terminating impedance was changing, so we just kind of eliminated this whole thing altogether and used 0.775 volts as a reference, and we all measuring voltage in today's time. So again, it's just to show you that these are some calculations that we'll be using now going forward. And some also show DVV. In DVV, the only difference is जो आपका reference voltage है 1 volt है 0.775 के बदली में, और जो the difference between DBU and DVV is 2.2 decibels, जहाँ आपका DBU will always be 2.2 decibels more than your DVV. इनपुट सेंसिटिविटी, जो आप हमेशा एम्पलीफायर के पीछे आप देखेंगे उसका वोल्टेज गेन या इनपुट सेंसिटिविटी दिया गया है. For those of you who who've seen amplifiers behind many amplifiers, like we sell a lot of amplifiers, behind those amplifiers हमेशा एक स्विच दिया गया है 0.775 वोल्ट या 1 वोल्ट या 1.4 वोल्ट्स. ये वोल्टेज का मतलब ये है कि व्हेन यू गिव, आपका जो इनपुट सिग्नल 0.775 वोल्ट्स होगा, दैट इज गोइंग टू बी गिविंग यू द मैक्सिमम output voltage, and just before clipping when you give 0.775 volts, if it is, अगर आपका input voltage 0.75 के नीचे होगा, that's fine, but 0.775 will be the maximum voltage that you can apply. Same way it goes to 1 volt or 1.4 volts. It means that is a maximum input voltage that you can apply to the amplifier. जो आपके mixer से या crossover से आपका जो signal आ रहा है, उसका maximum voltage 0.775 volt या 1 volt या 1.4 हो, that is the maximum input you can give to the amplifier. ये input switch change करने से आपका amplifier का power rating कुछ change नहीं होता है. Many times what happens is when you change it, let's say if you're using 1 volt and you change it to 0.775, आपको लगेगा कि signal या आवाज़ बहुत जोर से बज रहा है. That is because you just increase your sensitivity. मगर अगर आपका एम्पलीफायर का मैक्सिमम आउटपुट वोल्टेज, आउटपुट पावर 100 वाट है, अगर आप 1 वोल्ट दे रहे हो या 2 वोल्ट दे रहे हो या 3 वोल्ट दे रहे हो, द मैक्सिमम आउटपुट वोल्टेज विल ऑलवेज बी 100 वाट्स. बट अगर आपका सपोज सिग्नल लेवल 0.5 वोल्ट्स है और आपका इनपुट वोल्टेज सेंसिटिविटी 2 वोल्ट है, तो आपका एम्पलीफायर में एम्पलीफिकेशन, जो वोल्टेज एम्पलीफिकेशन है वो कम होगा. और अगर 1 वोल्ट पे आपने स्विच किया है, 0.775 वोल्ट पे स्विच किया, और द वोल्टेज एम्पलीफिकेशन इज गोइंग टू बी अ लॉट मोर, बट इज गोइंग टू बी रिस्ट्रिक्टेड टू द मैक्सिमम आउटपुट. आपका जो मैक्सिमम आउटपुट पावर एम्पलीफायर का वोल्टेज है वो 100 वाट ही रहेगा. इट विल नेवर गो बियॉन्ड 100 वाट्स. दिस इज बिकॉज आपके अलग अलग मिक्सर्स या डीजे मिक्सर या अलग अलग इक्विपमेंट है. आपका सीडी प्लेयर होगा या अलग अलग कंसोल्स के आउटपुट वोल्टेज में फ़र्क आता है. You will notice that some, I've seen Yamaha and Soundcraft not having the same output voltage. So to ensure, gain structure and enough, to control your gain structure and make sure एक छोटे से fader के movement पे आपका amplifier ज़्यादा एकदम जल्दी से gain नहीं होना चाहिए. That is why the input sensitivity you can adjust. So the amplifier that we are using today, thanks to a good friend Brian Sound, has given me a Lab Rubin FP 10,000Q. And behind that the voltage gain is set as 32 dB, and so we are going to be using a value of 32 dB. That means आपका जो amplifier है is giving you a voltage gain of 32 dB, and threshold is in dBu is 20 log V, whatever your input voltage divided by 0.775. So any number that you want you can calculate. अगर आप SPL आप for example 2 मीटर पे measure कर रहे हैं and you're getting, and you want to know the SPL जो उसका value है, you want to know what is going to be the value of that, and you know that is going to be dropping by 6 decibels every doubling of distance. So if you had 2 meters, you say have 100 decibels, you want to know what is the value of the SPL at 16 meters. So 16 divided by 2 is 8, which is again 2 into 2 into 2 into 2 is 8, and every 2 is going to be dropping you by 6 dB. So अगर आपका 2 मीटर पे SPL 100 dB है, आपका जो 16 मीटर पे SPL should be dropping by almost 24 dB, which is 100 minus 24 is 76 dB.